In this video, we are going to extend what we already know in 2 dimensions to 3 dimensions. So if they give you 2 points and you have the initial point, so that's P with 2, 0, 8, and then point Q with coordinates -5, -5, 3. So please pay attention to the difference in notation. So when you see parentheses, you immediately think it's a point in 3 dimensions, right? Now, if you want a vector in 3 dimensions, you've got two different equivalent forms. One is called the component form. That's using vector brackets. So when you click inside the box, it usually tells you what it wants. If it says enter a vector, it means, and then you click on more, they will tell you what format. So you can see that less than, more than, that's called vector brackets. That's what you want. And that's called component form. So vector PQ is going to be in component form. Now it matters which one is the initial and which one is the terminal. So this is initial, and then this is the terminal. So you want to subtract the coordinates of the initial point from the terminal point. So start with the terminal point first, always start with the terminal, subtract initial, okay? And be careful if subtracting a negative. Well, here we don't have any negatives in the initial point. Okay, so we're gonna get -7, -5, and -5. That's gonna be the component form. What's going to be the difference with the standard unit vector? So just like we had in 2 dimensions when we had ij, now we have ijk. Okay, so how does that look like? So let's just say you have these axes, right? So this is the x-axis, and this is, let's say, the y-axis. Oops, chose the wrong one. This should be this one. Okay, let's just say that this is the y-axis goes here, and then we have the z-axis. So yeah, it's gonna go like that, right? So what is ijk? So I is going to be vector that is going to be along the x-axis and has a unit length, right? Which means length of 1. J is going to be along the y-axis, so this is your j, right? And then k will be along the z-axis and also will have unit length. So those are your standard unit vectors, right? So this is your x-axis, y-axis, and z-axis. All right, so those are the vectors. But what is vector I? Well, vector I is just 1, 0, zeros, right? Because you're only moving along the x-axis and not y or z. And then j is going to be 0, 1, 0 in component form. And then k is going to be 0, 0, 1, as you probably realize. Okay, so how can we express this vector in standard unit using standard unit vectors? Well, what you can see is if I want to multiply the I vector by -7, and then the j vector by -5, okay, and then the k vector, but also by -5. So that would be 0, 0, 1. Then when I do the operations, right, so distribute the -7 here, this is going to be like -7, 0, 0, plus, then distribute -5, so that will be 0, -5, 0, and then plus distribute -5 over here, so that will be 0, 0, -5. And if I were to add up all three vectors, then I'll get -7, -5, -5, which is back to what I started with. So you can see that I can represent this as -7 multiplied by the 1, 0, 0, but that's I, right? And then I can do -5 multiplied by 0, 1, 0, which is j, right? So I'm going to say, okay, that's -5j. And then I also have -5. And then what is this? 0, 0, 1. That's k. Notice the notation. So compare, be careful comparing the notation. In component form, you want vector brackets, right? And you have to use commas to separate the coordinates, or rather the components of the vector. In standard unit vector notation, there are no vector brackets and there are no commas. You are just adding number, whatever the component is, multiplied by I, and so on. So this is going to be -7i, no commas, -5j, and then -5k. So that will be using standard unit vectors.